All right, thanks everyone. So today we're going to talk about size optimizations, some techniques to apply for size reduction, and roughly I will go over what you can do within Yocto framework to reduce size of your firmware. What tools are available that you could deploy to help yourself. And then I'll also talk about some of compiler tools and optimizations, as well as some of advice on, like code restructuring and some design choices that can help you to write code in C++, which is better at size compression. And then package refactoring. As you know, we have package configs in Yocto, and so essentially that's what we're going to cover. And package selection. So package selection is all about, we have alternatives, and making those choices can also help you reduce the size. So that's pretty much agenda. If you have questions or comments, I will be on Slack, or we'll have some time, hopefully at the end of the talk, and we can have live session as well. So feel free to ask questions. All right, so what I am going to show is basically a distro I maintain, which is driven out of Poky, which is the standard distribution from Yocto Project. So if you see in Yocto, essentially you will see 3 distributions policies that are available for you to use. And Poky is the standard default distribution that you'll get when you check out, do nothing, just follow the quick start guide. But then you can choose with a distro variable. You could set that to poky-tiny or alt-config. And then you can use one of those. So the differences are that poky-tiny is geared more towards smaller sizes. So it has made some distribution policy decisions that help size. Essentially, it uses muscle for C library, which is smaller in size. And it has a smaller versions of kernel. Linux Yocto Tiny. It doesn't use UDEV or systemd UDEV. It uses MDEV for device management, and it has a custom init script, which basically can run on the BusyBox shell. You could also use BusyBox init, which is similar, provides you init tab and stuff, and we'll talk about that a little later. Alt-config is, it uses systemd for init system. The default in Poky is 5init, and it uses LTSI kernels. But anyway, these are like the choices you have in there. And, for size, poky-tiny is essentially a good choice to start. You might customize it a little bit because, you might use a different kernel. You might want to use, BusyBox init or maybe sys5 init, but largely the policies it defines gives you a good framework to start your distribution. So I highly recommend it to look at the distro definitions in poky-tiny. All right, so how do you customize? Basically, you can simply inherit the poky-tiny policies into your own distribution policy or distro policy file that you're going to create, right? And you could name your distro whatever you like, and then you can do further customizations here, right? And you might want to select what you want to use to do network management, and what SSH you want to use, and there might be other things that you want to use, right? So it starts as simple as that, and you can customize from here on as much as you like. So what I did in here was I basically took few optimizations, and then I'm going to show you through those, and hopefully that'll give you an overview of what can be achieved. And I'll also discuss what are some of the things you need to keep in mind when you make those decisions. So we'll go over package selection. So in core, we support two libraries. We support glibc, which is the default, but then we also have muscle, a C library. And what I'm showing you here with respect to sizes is actually just the size of the full image, right? And it is just that when you just change the C library, you are able to save, a few megabytes, and that's pretty neat in there. But when you work with changing libraries, so this comes with some design considerations that you have to keep in mind. So this is a decision you make at very early stage, right? So it is not something that your boss came in and says reduce the size, and you say, all right, let's go for muscle, right? The reason is it may not be compatible with glibc, and you might have third-party code, and you might have pre-compiled code that is, in your full firmware. So you will basically have to iterate through your support system there to make sure that all those firmwares are also compiled for muscle. So so I'm always recommending this as your first choice when you start with Yocto project. Make sure which way you want to go, or at least have that leeway where you can select what you want. There are ways to kind of bridge, some of the pre-compiled applications onto muscle, but then you are kind of treading, path that's less traveled. So if you understand that, yes, our system footprint needs a C library, and you have an idea of, okay, it's self-contained, we do not have any third-party dependencies where we need to worry about it, or we have a plan for that. Use BusyBox in its system. The reason is BusyBox is one in all, and it also provides a init system to you. So why not? When it is there, it's another applet, just use it. It provides you, the init levels and that sort of stuff that you had from sys5 init. But it's fast because, there is no fork exec going on there. So if your system is really small, this really is very good option to start. So so I started comparing with the alt config, which means I had systemd on the box, right? And then I switched from systemd to BusyBox, and my image size went from 35 meg to 3 meg. And the reason there was that I think, there are dependencies that systemd was pulling in that got dropped as well. And use mdev instead of udev. Usually on smaller systems, number of devices you have are limited. You already know. So, udev might not serve as much as you would think. Udev makes sense when, hardware is pluggable. It's very useful in these situations. Not to say that it's not useful in here. It is definitely, but if your hardware is pretty much contained, you could probably live without it. And that basically means that, you need notifications for devices from the kernel, and you need something to capture it. UDEV might be a right option there, that can serve you. And it is limited in features, of course. You'll have to look through that because, there is no libudev, that if you have programmed your applications to use in those APIs, they may not be available. So again, an early decision, right, at that certain point that you say, well, if we stay with UDEV and we define it differently, how you want to access those. check your global optimization flags in Yocto project. So there is a variable called selected optimization, and it is set. So there are certain defaults it has, and by default, what you get out of box is -O2 with -G, which is the most commonly used options anyway. This can basically, this gives you best performance, or I would say like, best of both worlds. But then when you're targeting size, you might want to use the OS option, which is optimized for size. And once you do that, you can see that the image size goes further down. Again, OS comes with compiler, but when you see number of packages being tested with this is small, right? Or I would say that number not small, but number of people using it as an option is small. So there might be bugs that you might find in the packages that you're compiling with OS, or there might be bugs in compiler itself. And that is one risk or one area that you have to keep an eye on when you use optimizations for size. Some packages aren't compiled regularly and tested regularly with optimized for size, and they may behave differently. A runtime, for example, compiler runtime is a interesting piece that may not work at all because it has made some assumptions about the function code generations. So those areas you might have to look at, and you might have to use O2 in certain situations on certain packages. But this is a good option to start because it ends up giving you somewhere between 3 to 5%, sometimes more, but good option to look at. So further now, I'll go over a few more advanced options that you could try. No guarantees that this will give you a lot of optimizations, but it depends on your use cases. So, and some of them might be already, OS is already taking care of, but they are options you should know. So I thought I'll just list them here. No function sections. So there is this option where you can emit every function into a section of its own, and that's good because compiler can eliminate functions, right? So if a function is unused, it's easy for linker or to find it is unused and therefore not generated in your final option. So look at this option and try to see whether F function sections is the right option for you to hear. No unrolled loops. So this basically means that if you have loops in the code, don't unroll them. Loop unrolling increases the size, right? So if compiler finds you're looping 100 times, it might turn that into a loop of 25, but then execute the code 4 times in each loop, right? So, but that means that it is going to increase the code size, and you really don't want that. If you don't unroll loops, you might have to give up some of the runtime performance. Similarly, if you're using C++, don't use exceptions. You can just specify that if you're not interested in exceptions. Exceptions has a runtime overhead, right? So in every unit, it has to emit those exception handlers, and that adds basically quite a bit of code to every function. No jump tables, that's an optimizations which basically make sure that you generate a table for all the case and case statements and stuff. So that also causes duplication because every jump table is actually going to give you this conditional codes, which otherwise you can do in loops. So these are just a few of those that I've listed here, and I'll also suggest some of the code architecture that you might want to be careful about. So if you look at like standard libraries, libstd++, which is C++ runtime library, or any other C++ library, Boost, or you name it, right? And the commonly used libraries. What do they have? They have all the functions. They are defined in the header file. So you include a file, a header file, a benign header file into your source code in C++. But then they have these function definitions inside there, right? Template instantiations. What happens? They get added to your C file, even if you're not using it. So as a result, if your C++ file becomes bigger, right? A lot of people complain that, C++ code is bloated. The reason is all this, because if you use explicit template instantiations, then it will not do that. It will actually explicitly use only those templates that are being used in your source code. So it'll have two effects. It will reduce the code size, and it will compile faster because it doesn't have to deal with all these static template instantiations that it is having there. So very important. If you're not doing it, go look at your C++ code, and you might find something there. And compiler is smart at inlining these days, right? So it knows a lot more about functions and makes independent choices. When it can inline a function, it will. You could basically see if a function is being used in several places, right? Then you might want to say, hey, don't inline it, right? Because you're worried about size more than anything. If it is like one-off, okay, you might take it, right? Because inlining doesn't matter. But if it is used in like, say, more than 10 places, then you have like 10 copies, you probably don't want it. You can qualify your function with the attributes, right? And help the compiler basically say that, okay, this function is out of picture for me. A little bit more. Like I mentioned, for the standard libraries, follow the same design in your own libraries. And so do not define functions in headers, for example. The reason is same, they will become the candidates for inlining, and they will be inlined. And the common ones are like constructors, destructors, operator overloading, so they are used everywhere. So what you see then is your code getting copies of those everywhere you use them, and code becoming bigger. But if you kind of move those definitions into your source files, that is your CPP or CXX, whatever you call them, then you'll have one copy. Very important, you could also have additional annotations that will help the compiler. So pragmas and function attributes that you could use. And I highly recommend to look at them if you haven't, but a couple of them are listed here. The cold attribute, basically very interesting. It tells that, okay, this may not execute, right? So there is, it might inline it or other things, right? So compiler has information that you provided that this function is not a hot function. You can also say, don't optimize this function, or optimize 0 means optimize for size, actually. And so you could also use other attributes, but if you're optimizing for size, go for it. And use cheaper data structures, right? So if you're doing C++, use list instead of vectors, right? What you'll see in the generated code is that the code that list generates is way smaller. It might have trade-offs, and depending on how you're doing your data structure alignments, but generally, if you're sensitive to code size, this might be a good trade-off to make. And finally, use compiler built-ins wherever possible. I've seen many places where people write their own functions thinking they are much performant, but that's not true. I've personally validated this claim hundreds of times. No, we do not know more than compiler when it comes to optimizing. And it is good to use whatever compiler is providing as a built-in as an option one. And in exceptions, yes, you might want to write one, but have a very good reason to do that. Similarly, use standard C library functions. They are better optimized. So don't write your own printf or your own subset of libraries unless and until needed. Try to use the standard optimized library function. That, if you keep these things in mind, it gives a size reduction in your applications will be automatically improved. All right, so moving further a little bit, you could also get further help from modern compilers. Use link time optimizer. Link time optimizer is relatively new, and new in compiler speak is 5 years or maybe 10 years. But yeah, this is actually fairly recently done feature, and it has taken years and years. And more distributions are enabling it by default now. If you see, I think Fedora latest, I don't know, whatever version it is releasing right now, is built with LTO. So which means it is getting mainlined, being used everywhere. What it does is it basically compiles everything into intermediate code and then feeds everything into the linker, and linker calls the optimizer spec again. Because now linker has a view of the whole program, not only just one compilation unit or one file that you were compiling, it can do much better because it can do intra-procedural optimizations, right? And a lot more at a whole program level. So what you see is, it reduces size. In my case, the size reduction is few bytes. The reason is that I was only running it on one application, because back then I didn't get many of those applications compiling with FLTO. Maybe it is better now. But it is a good option to have. It can do more aggressive kind of like cleaning or removing dead code and stuff like that. And I've given some constructs here that you could use in Yocto Speak to enable it. It will work with both Clang and GCC right now. So pretty neat. Clang also supports thin LTO, full LTO. So I want to mention this. The reason is LTO will increase your compile time quite a bit. And the reason for thin LTO, full LTO is again same. You want to make a compromise between your compile time and how much juice you want to squeeze from the optimizations. One thing is that when you enable LTO, it will either need Gold linker or the LLVM linker. And right now, there is an anomaly. It doesn't work with OS. And there's a bug open in LLVM for that, but it hasn't been yet addressed yet. But it works with O2 and O3. But something to look at as you move into future. Okay, so we can now talk about some of the tools that are in the project. And go over them, how they can be helpful to you. Build history. So build history, if you're not familiar with it, is noting down a lot of details about what's happening during the build. And so enable it, and then we'll see what all we can use it for, right? So you enable the build history in your local.conf, and then build an image. And there onwards, it's going to record the details about build into the build history repository. This repository is actually a Git repository. So you could basically go from build to build and back and forth. Okay, so image language, that is something that you might want to look at. This is very important that if you're not using any localization, then you may not need it. So you might prefer to keep it empty, or choose the languages that you really care about. That will reduce the data in your images, the localization data. So that's pretty neat. And there are certain image features that you might want to remove. So if it is a deeply embedded system and you're doing, you know, firmware updates using different methods, don't use package management. It will kind of avoid creating that package management databases in your images. Remove splash, right? So if it's not headed, you don't need splash. And for SSH, you could use drop-bear instead of OpenSSH. So these are some of the the package choices I was talking about you can make at the very beginning. But these, so for example, using drop-bear instead of OpenSSH, talk to your security team, right? And ask them, is that something we could do? Because in many cases, they may not agree to use, drop-bear. It may not fall into the policy or, the security policies that they might be recommending. So default tunes. So David, how am I doing the time?
You have until the top of the hours. You have about 8 minutes.
Okay, thanks. Default tunes. So look closely at them, right? One of the strong points of Yocto Project is that you could basically customize what all you can use with the, how you can compile the whole image. And it allows you to choose a lot of distro or like machine features that you could enable. And for example, if you're building for 32-bit ARM, use the thumb instruction set, right? That's a 16-bit instruction set. It's compressed. You get smaller code size. You get faster performing code as well most of the time. So if your CPU, that is, because ARM has many of those, so check that. If it is supporting the thumb instruction set, use it. It will basically give you better compression for instructions just by recompiling your code. So how do you identify that? Check your default tune value, for example. And if it has this T in its name, like after the CPU implementation, then it will enable the thumb optimizations for ARM. Similarly, for MIPS, there is a 16-bit ACE instruction set. You could enable that, the MIPS 16E, that is what it is called, similar to thumb, right? And you could set the MIPS instruction set to MIPS 16E, and that will basically compile your code using the 16-bit instruction sets for MIPS as well. It's exactly similar to what thumb does. All right, so I talked about build history. And if you look at the build history a little bit, what you see is there are a few files. And I went into, so it basically is recording not only for image, but also build history of whatever it is building. So what I'm showing here is actually the build history of the image itself. And there are a few interesting files in there. There is this build-id.txt, but then what you see in there is some of those dependency files, right? And they are very important. You could view them in some, .e viewer, but you could also open them in a text editor like me. And then they are basically a key value pair kind of situation, right? So A depends on B. And so you could basically track the dependencies that way. And then it also lists you some files that are in the image. So you can look at what all files are going into your image finally, right? And if something sounds unfamiliar, you could then trace it back, who is adding it. There's image info, which gives you like information about what all package groups are going in there, what size it is. And then there are names, like, the image is constructed by using like, IPKs or RPMs, what have you. So those names are recorded here. So you can basically at a package level check that, yes, this package is not required. How is it coming in? And then you can trace it back. And then it lists you the package sizes in order. So you can basically look at and say, here are my top 10 packages that are contributing to size. What can I do about those? So it's a very important information when you have this, myriad of packages and where to concentrate. So this gives you a very good starting point, so to speak, that where, if you can optimize your top 10, you'll get 90% of the gain in size. Okay, so just going a little bit, zooming on one of those. So if you look at like the installed package sizes, that's what it looks like. So you can see Blue C5 is about 3 meg. Shared MIME-info is 2.5 meg. Do I need it on my target? So you can like ask those questions. libc, probably you have to have it in there. But then can I use glibc? This is what glibc is showing. It's about 1.6 meg. Can I use muscle, right? And how much that size will be. So, and then there are modules and so on and so forth. So it's very handy. And as I said, it has other information about the DOTI files. And this is what it looks like. And as you can see, it gives you the dependency. For example, if you look at the last, the first one, 96 boards tools is in my image, and it depends on E2FS progs resize FS. So if I haven't added E2FS progs resize FS into my image install, then 96 boards is pulling it in, right? That is the inference you can draw. And then if you want to remove this dependency for whatever reason, you can go and look at 96 boards package and decouple it. So that's the way to kind of, optimize it further. Okay, so other things, kernel tweaks. So sometimes some BSPs, they enforce all the modules because that's what their reference testing is. You might want to look at that and prune that, right? And you want to remove, no, I don't want all the kernel modules. I only want a handful of them. So add that to your machine extra recommends. Then there are a few options that you could use, and I think you'll get them in the Linux Yocto Tiny as well. For example, you could enable CC optimize for size key config option, and then you could use XZ compression and the config slob as well, which is kind of going to help with the memory. And you could also avoid duplicate images in kernel, because many cases you put an image in a different space, right, in a different partition. If you do that, then you might want to see that it's not generating a kernel image into /boot in your rootfs, because that will be a duplicate image. So important to look at that. And then look at your kernel config. There may be some features you really don't need, disable them. And as I mentioned, compile for small features. So I've given actually a good link here that you can look where I've done some comparisons on what it looked like when I chose different options for C library and so on and so forth in different init systems. I won't go over it, but if you have some further questions, please follow up. All right, so some future work. And I did experiment with Toybox. It hasn't yet panned out to be a full init system for me. So keep an eye on that one. LTO, we have started to enable it, not in Yocto project yet, but on package by package basis. On some packages, it's yielding a huge benefits. And that's very encouraging. And maybe I'll kind of submit the patch once again for master now that Gatiscuth is released or is going to be released. Additional compiler options, I think I discussed a few of them, but there are more that we could always talk about. And I plan to do something on Go and Rust as well. So in future, watch out for that. So that's all I had. Thanks for all your time and listening to it. Hopefully it was useful to you. If you have any questions, or do I have time? Probably no, but I can take one question or so. If not, then we can move on to Slack and we can discuss it there. Thank you.